Today I'm just doing a few small, gentle jobs. I ended up hurting my back earlier this week, and it's been quite painful for the rest of the week. I'm only just really able to move around without it hurting too much. So I'm sticking to nice, simple, easy jobs at the moment. And one of the things I decided to do was sort out the tubes, the control tubes that run down the center of the steering column. So those are these two tubes. They run, this one runs inside this one, and this one runs down the inside of the steering column. The controls, one of them is for advanced retard on the magneto, and the other one is for hand throttle position. And it's been a bit of a disaster with these. So the first problem I had was one of my own making, which was at one point I listened to some bad advice from the UK where they told me I needed to shorten the steering column. And I went ahead and did that, and it turns out that was wrong, which Joss, my mentor, told me it was wrong, and he never let me forget that, which was quite funny. But luckily we had another steering column and ended up using the proper length one, as it's supposed to be. I believe a lot of the guys in the UK shorten them for racing reasons, because you've probably noticed this isn't going to be the easiest car in the world to get in and out of. But sitting so low and having such a huge steering wheel effectively right up in your chest, it makes the car rather tricky. I'm not even going to try and sit in it now with my back still hurting a bit. The problem with the shortened steering column is, yes, it does move the steering wheel this way a bit, but on this car that wouldn't work because the curvature of the door comes up here. And if you move this back, you're going to end up hitting the door. And then I don't want to have to start modifying the shape of the door, because then it's not a proper Brooklands, and so on. So this is the proper length steering column. The problem with that is I had also shortened the control tubes. So I've taken these apart, I've stripped them all down. They needed a really good clean out. I basically had to keep shoving little pieces of cloth soaked in degreaser and pushing them down through the tubes. And that caused another little bit of a disaster when one of these pieces of cloth ended up getting stuck in the tube. To get it out, I ended up using a piece of bar and hammering it through, which was working fine, but the bar was too short, so I used another length of bar to hit the first length of bar. Some of you can probably see where this is going, but the bar I was using was too narrow, and the two pieces of bar ended up going past each other and completely jamming inside the tube. And effectively it meant the tube split about here. So because I was already lengthening the tube, it wasn't really that big a deal. You can see where I've added an extension on the end of this tube. And this tube is 1/2 inch out of diameter, which I had. And this other one is 5/16, I believe it is. The inside diameters are a little bit weird, but obviously because I've got a lathe, I was able to machine those out to be correct. And the way I join these is I machine this down. Even though it's quite thin wall tubing, there is enough tube there that you can slightly open one out and slightly machine one down. And I made them a push fit, and I'm just using Loctite 638, which is incredibly strong stuff, so that won't come undone at all. And these only have to transmit rotating forces anyway, and there's not a lot of stress on them, so this works fine. So that's extended, and I had to do a similar thing with the inner tube as well. These are actually copper. They're soldered onto the tube, and then there are these sort of little copper finger type things, which basically work kind of like bearing surfaces, and I think sort of anti-rattle. So when these are all assembled, they're very well centered. They don't rattle around, they don't vibrate or anything. It works really well. I just carefully took those off. One of these had actually broken. These are literally just little pieces of copper pipe that they've cut little strips off and slotted, and then they're just soldered onto the steel tube, just soft solder. So one of those had actually come loose. On the original one, I just resoldered everything up. The reason they're all silver like this is because there was some evidence of rust pitting on these, so I just cleaned all of that off, and this is just some very high zinc, very high silver paint. I thought there's no harm just painting those up. So those are now the correct lengths, and they all fit back together. I'll put it all back together in a minute and show how that works. The other really big problem I had was this tube, the inner one. You can see on the end here there's two little holes, and this is actually where the horn button goes. There's a button that sort of screws onto there, and so you need a wire to run all the way down the inside of this tube. And the original wiring they used on these cars was fairly thick gauge copper wire, and I'm guessing it would have been fabric insulation, sort of cotton type insulation. And what happens is over the years that insulation breaks down, and it was just completely stuck on the inside of this tube. If you try to pull it out, all that happens is the wire breaks, and this is just completely jammed up. So the only way to get that out is to drill it. And I knew that would be a method. I just wasn't sure if that would work or not. But luckily someone on the forum mentioned that they've had to do that on vintage cars as well, and it's worked for them. So that gave me the confidence to try it myself. Of course, that means you need a drill bit that's sort of 3 feet long. So what I ended up doing is making this thing. And it's a bit hard to see. It's actually very long. This was just an old drill bit. I don't think it's going to focus. There it is. This was out of my blunt drill bits box, and for the shaft I needed a very long straight shaft, obviously, and I couldn't think of anything I had that was suitable. And then I realized, oh, it's I've got some fencing wire. So in best New Zealand tradition, I used a piece of number 8 fencing wire straightened out, welded that to a drill bit at one end, and then I had to weld another one on the other end because using the small end, I was able to drill out the copper, but it left a lot of the insulation stuck on the inside. So the larger end helped me clean out the insulation. It drills fairly easily. The biggest problem is you have to go really, really slowly and take your time, because it generates an awful lot of friction. And obviously you do not want this getting stuck inside there, because you would never get it out. And I had one scary moment, you might be able to see, when this did actually catch and it actually started twisting the wire. I think this is probably an advantage of using this it's not high tensile wire, it's quite soft fencing wire. It wouldn't break, it would start twisting before it would snap, because if this had snapped inside there, I never would have got it out. So I had one scary moment where it did start twisting up, and I had to slowly reverse it, and I let everything cool down first, because the amount of friction trying to drill through the middle of that is just insane. And obviously you need to keep clearing the old crap out of it, which is why the floors in my bench are all completely messy. So you would basically push it in a little bit, drill a little bit, pull the whole thing out, clean all the crap off it, and then just keep doing that. It took me a long time. Once I'd gone all the way through with the smaller one, I was able to then go through with the larger one and really clean it out. And then once I was all the way through, I went in from either direction until it met in the middle, to avoid trying to any compacting of it. And then once I was all the way through, you could now push this all the way through. So that's good. That means I now have to recreate the horn button on the end, but I've got pictures of that. I think I've actually got one, but it's broken. The parts of it are broken. And I can run a wire all the way down the middle. So I'll put them down back inside the column and see what they look like. This is how the levers fit inside each other and inside the steering column. So they provide you those two controls there. At the bottom end, it all gets a bit weird. And I'm not actually sure how this goes because I've never really seen it fully together. There is, I've got a random collection of bits, of course, as per usual. And there is this cross shaft thing, which I believe, I believe this is something to do with the throttle. So the pedal just fell off. But if you imagine you've got a throttle pedal down here, there's different ways of setting this up, and I've seen it done in multiple different ways. But I think one of the ideas is that the throttle linkage goes here, and this kind of transfers it across to the other side, because this is the inlet side. You'd have your carburetors here and some sort of throttle linkage up here. This is where the two tubes poke out the bottom of the steering box, and there is a sort of plate that I believe fits on there with a spacer. You can see there's a boss there for a threaded boss, and there's another one here, but there's a spacer needed in there. And somehow these levers go together. I don't actually know how this is supposed to go together. There's also the return spring on it somewhere, all up in here. And I believe the idea is to couple the accelerator pedal across the steering box up to the carburetor linkage, but also somehow allow for the hand throttle control. So by setting that control, it'll move this arm, I believe, somehow, to allow you to do that manual throttle setting. And the reason you have that, I'm not entirely certain the exact reason. I had an Austin 7 Chummy that had a similar sort of setup, and the reason for having that was mainly so that you could start it. You could give it a little bit of throttle for when you were hand cranking it. So I'm assuming it's the same on the Riley. I don't really know. But it would be nice to have that there and working. Obviously, it's not essential because this has got an electric starter motor on it anyway. The inner tube is going to be essential because this car is going to be running a magneto ignition system, and you need to be able to manually adjust the advance and retard. So there is another little arm that must go off here, which I don't have at all. I don't have whatever it is that clamps on there, and that goes up to the magneto, which sits vertically here off the timing case cover. So somehow there's a linkage that goes from here up to the little arm on the magneto to change the advance retard setting. So, like I say, this bit is still a mystery. This isn't essential, but it's just good to have the tubes back to their proper length and back down inside the column. This is just, that was just some of the wads of clean rags. I just had to keep pushing down there, shoving them through, just pushing them all the way through. It took a long time to actually clean it out. I suspect what happens is over the years these tubes come up, and instead of taking it all apart, people just squirt more and more grease or oil or whatever they've got down from the top, trying to free them up and keep them moving, and of course that all just stays in there and gums up. So these, I've just put a very minimal amount of lithium grease on them for now, and they move pretty freely. So obviously there needs to be enough friction in the system so that when you're turning the wheel, you're not moving the levers. So I'm not sure how that works exactly. I'm assuming that once everything's actually hooked up at the bottom, it works out that there's enough friction in the system so that turning corners doesn't change all your settings. But I won't know that until I actually get it hooked up and see. Another small job was my 3D printed version of the terminal cover on the dynamo. This was the reproduction one, and I decided just to try and make my own. It's taken quite a bit of playing around just with the modeling and trying to get the printing correct. It's quite a hard shape to reproduce, it turns out. It was an earlier attempt which is close but isn't quite right. This is the one I've gone with for now. I may still come back to that and have another go, but that one's a lot closer. I didn't bother trying to polish it up too much, and I forgot that there's actually a little sort of plastic grommet in there, which means the base of this doesn't sit flat. Obviously that'll be a problem on this one as well, but I may put a little bit of a gasket or something under there just so it is actually sitting completely flat. But that's not too bad. Inside there are two little brass terminals to attach the wires to. This is good ABS plastic, so it should be nice and solid. I need to just tighten up that screw there. To stop this rotating, I actually put you can sort of see it here, there's a hole and a corresponding hole in the top half, and there's just a little pin in there which just stops that rotating. So I just need to screw this down tightly, and when the car gets wired up, the wires will just go into the front there. So that's another thing that can just go back up on the shelf for now. I've also been trying to figure out exactly how this oil setup's going to work on this engine, so I can order some parts and actually get it finished. This one has been modified to have a external oil filter. Normally the way this works is, put that down, you have your oil pump here on the front of the engine, and this is a plunger pump. You can see there's two plungers there driven off eccentrics off this intermediate gear. So these two plungers plunge up and down, and you can see this is the oil pickup tube, comes into here through the pump, and then it normally comes out this tube here. We can sort of see it a bit better on this original one, where this is where the pump bolts on. This is your pickup tube, and then it normally just outputs straight to this manifold, which is this one here. It's also really important to note that if we look on the back of the oil pump manifold, you've got your two mounting holes on the side, your inlet hole, your outlet hole, and then there's this extra little hole at the top. And you can see there's space for a fitting there. It's a bit hard to see on my engine because it's buried, but that's down under there. And that's the feed to the rocker gear. So when you fit the oil pump, there's a gasket under here. You have to make really sure that that little tiny hole isn't blocked. That feed, I get my pipe. Basically there's a pipe that goes down the inside of the block in there, and it comes out this front timing cover somewhere. I'm guessing through this big hole here. Remember, these two holes have the camshafts, so there's two other gears that go in here, but there's room in the middle here for a pipe. And then there's this threaded brass hollow thing that goes in the middle, and basically the pipe comes out of that and it goes to this Y pipe setup. This is where I confused Mr. Tweed, I think, by saying that this was homemade. And what I meant is this particular example is obviously homemade. I realized that the oil setup is completely standard Riley. This has obviously been made by someone. These aren't proper banjos, so that's where I have no idea how they expected that to work unless they use some sort of special bolt, because that's just a block of brass with a hole through it and a little hole in the side for the oil pipe. The correct fittings are available, and I have ordered some of those from the spares, so they're all on the way. But basically, that oil pipe comes down to this Y pipe, and that goes to the front of each of the rocker boxes. So that oils the rockers. The oil then drops down back through the head onto the camshaft bearings. So that's what oils your camshafts as well. This manifold, put this down, which is where the oil normally comes into, is also the oil pressure relief valve body, as well as being the manifold. And you can sort of see on this one how that pokes through the side of the block, and there's a screw thread in there, and there's normally a ball in there, a little cup and a spring. So I've got all of those. You can also see how there are the two little takeoffs on the bottom there and the two on the top. So the two top ones, one goes to the front main bearing and the second one goes to the rear main bearing. I'm going to remake these just because these pipes are pretty old and mangled and a bit squashed. So I have all the pipe to do that now. One of the little smaller takeoffs goes along this pipe to another banjo fitting, and that comes through the block to a little angle fitting, and this is what goes to the oil pressure gauge. I'm not sure what the second one there is for, and not all of the manifolds have that. I have various bits of oil piping here. You can see that one has two, but this one only has one. So I'm not sure what that second one is there for, and I think on my engine I may end up needing to block that. Yeah, I'm not entirely certain. The other thing I have heard you can do is take an extra little oil feed to the intermediate gears to arrange to drop some oil on these to help keep them a bit quieter, but I'm not sure if that's something I need to do or not. Where this one gets tricky is the way they've tried to add the external oil filter to this engine. So this is the filter body with an ancient filter on it. That basically sits there. So that's not a bad place to put it. It's under the starter motor. It's out of the way. The problem is getting the piping through to it. So they've used these compression type fittings for the inlets and outlets, and there are these matching brass fittings that those go onto. And the way this seems to have been set up is the idea is you've got one on one side of the block on the inside and one on the outside here, and then you take the pipe from there to the oil filter. And what they've done is this actually threads into the block. It's tapped, but this one has obviously broken, and the reason it seems to have broken is because they've done the same on the oil pump body part. So this is threaded on the outside and on the inside, but the problem is this is the part that broke off. We'll focus on that. Because it's threaded on both sides, it actually makes the part quite thin. So I'm not sure if this is something somebody's done themselves or if this is a standard part you buy. So I need to figure out how to do that. What I was actually thinking of doing is using an old drain plug because there's more brass there that I can drill and tap. So I'm still trying to figure out what fittings I can get to do that. The other thing is, instead of using a fixed pipe that goes around the engine mount, which is a bit strange, the other way I could do it, of course, is with standard sort of barbs and rubber oil hose. So that's kind of the problem at the moment. These are the little bits that actually go inside the pressure relief valve. So I had one here a second ago. This is an original one. So I think the way this goes is the ball goes in there. There's the little brass cup thing, and then the spring, and then this screws into there, and that's how you adjust the relief valve. But this is the bit that's interesting. So you can see they've done the same thing here, where they've made effectively a sort of bush so that you can have two of these screwed in. Although in this case there's just the one on the inside. So that sort of screws in there. This fits like that. And then the oil pump bolts to that. So at least now I kind of know where all the oil piping goes. One thing Riley changed over the years is, if you imagine on the original one where this pipe just goes straight through, because of the nature of the plunger pump, it doesn't give you a steady oil delivery. It actually gives you sort of pulsing delivery. And it actually sucks oil back, apparently, on part of the stroke. So oil's going both directions. And this would cause fluctuations on the oil pressure gauge. So to fix that, they had what was called an air bell, which is this thing. It's just a hollow brass tube. And that would fit in this line, effectively down in here. So it's out of the way of all the rotating parts. And that would help damp out the fluctuations. I don't believe I need that. One, I can't fit it anyway. There's no space for it anymore. And two, because it's going to an external oil filter, I think that'll have the same effect. It'll basically help damp out those pulses from the oil pump. So really all I have to do is figure out how to set this up so it's not going to be so weak that it breaks off like this again. So I definitely need to order more 1/8 pipe, this thinner pipe. I could reuse these, I guess, but again, you don't know how old it is, and if it's just straight copper, it could be fractured or it could break. So I'd rather redo all of that and know it's going to be good. I do have all sorts of random brass fittings and bits and pieces, but I'll see if this is actually a proper part, where it is actually threaded like an internal thread and an external thread. I think somebody's actually made that, and that's where the problem is. There's just not enough metal there to give you a decent thickness, especially if you happen to get the threads in such a way that they coincide at the weakest points. So I need to figure out exactly how I can do that. And then also figure out what that second takeoff port is on here. That it's a little bit odd. Because Riley had all sorts of different marks of engine, it actually gets quite confusing, the oil setups, because it did change over the years. And they started off, I believe, with these external oil pipes to the rocker covers. Then they went to an internal system where it's actually inside the block and it gets fed up into the head, and it has different rocker boxes. But they then went back to the external version. So that's what I'm going with, because that matches most of the parts I've got. I did also find my missing pulley wheel. It was sitting with all the oil pump bits. So this is the little pulley that goes at the rear, that the brake cable runs around. You can tell this one's pretty mangled, so I may have to make a new one of those, I think. But I've got most of the parts I need. It's just figuring out the best way to do these things through the block. I may end up having to machine something, but I've got plenty of steel. I don't have any brass big enough to be able to do that, but I think it would be okay to machine those up out of steel. And I do have appropriate taps. Just threading I can do on the lathe. But I think you're always going to have that problem where if you're trying to fit something into that tapped hole with a hole through the middle of it to take another fitting, it's always going to be too thin, the walls. So I need to look into that still. I just placed an order with Brass Fit up in Auckland for various fittings and little bits and pieces I need to be able to sort out the oil piping. It turns out there is a proper fitting you can get, which is called a bulkhead connector, I think, which is a threaded plug that goes through. It'll go through here. It actually has a nut and then a threaded thread on the inside, like a female thread on the inside. So I've ordered some of those, various other little bits and pieces, anything I thought looks like it might be useful, including a new coil of 1/8 copper tubing for all of this. You do have to be a little bit careful when you order these bits and pieces, because all of these fittings are British standard pipe. The dimensions aren't what you would expect. So, for example, this thread here, this is actually a 3/8 fitting, even though the thread is much bigger than that. And it's because it's all actually sized on the pipe. So, for example, this is 3/8 copper, and all of these threads and things are based on the size fittings that you would use for 3/8 copper tube. This is all 1/8. So, and this one here is quarter, because you can see the diameter of the tube is 1/4 inch, not the diameter of the thread. So that's something you have to watch out for. The other thing you have to watch is some of these are taper threads and some of them are parallel. So I think most of these are taper threads. It's probably a bit hard to see, but you have to kind of be aware of that as well, that there are parallel and tapered threads. So it all gets very confusing, but I think I've ordered the right things. I won't be surprised if I've got something wrong, because also often when you're ordering these kind of things, especially if it's a male and a female fitting, it's easy to get them the wrong way round, if that makes sense. But that's okay. It's always useful to have a stock of these things around. I use them for other bits and pieces anyway, so I've ordered some. We'll see what turns up.